Hello, dear students. Hope you are doing well. For today, we are going to continue our subject in Chapter 8, Section 3, which is about oxidizing and reducing agent. In this section, we will learn what's the meaning of oxidizing agent and reducing agent. Oxidizing agent and reducing agent. Reducing agent, it's the substance that has a potential to causes another substance to be reduced. Reducing agent, it means losing electron, the substance that attained became more positive oxidation state during an oxidizing reducing agent reaction. Oxidation reduction reaction. The substance that wanted to be more positive, this substance act as a reducing agent. And the reducing agent is oxidized substance. The reducing agent is an oxidized substance. The substance that oxidized act as a reducing agent. And for another part which is named by oxidizing agent. What's the meaning of oxidizing agent? Oxidizing agent, it's the substance that has a potential to cause another substance to be oxidized. Then oxidizing agent gain electron. The element that gain electron try to be more negative oxidation state during an oxidation reduction reaction. And the oxidizing agent, it's the reduced substance. The substance that's reduced is act as oxidizing agent. And now we learn about the strength of oxidizing and reducing agent. The strength of oxidizing and reducing agent. In order to know the strength of oxidizing agent and reducing agent, in the periodic table we have group. For example, group 17, its name halogens group. Halogens group contain fluorine, chlorine, bromine, and iodine. The fluorine atom is the most highly electronegative atom in this group, and also in all elements in the periodic table, fluorine atom is the most high electronegative. Most electronegative try to be most active oxidizing agent. How? Because it's strong attraction for one electrons, and also fluoride ion is the weakest reducing agent. The substance that try to be more negative is became weakest reducing agent. Fluoride ion is the weakest reducing agent. But fluorine atom is the most oxidizing agent. Why? Because it is strong attraction for the electrons. We have two kinds of ions. We have negative ions and positive ion. The negative ion of strong oxidizing agent, it's the weakest weak reducing agent. Pay attention to this point. The negative ion, strong oxidizing agent, it is weakest reducing agent. Most strong oxidizing agent is weak reducing agent. And The positive ion is a strong reducing agent. The strong reducing agent is the weak oxidizing agent. Weak oxidizing agent. It means the positive ion, how the atom became positive ion. After losing electron became positive ion. After gaining electron became negative ion. When the positive ion of a strong reducing agent is became weak oxidizing agent. For example, in group number 1, lithium atom are a strong reducing agent because lithium Li, lithium, the symbol of lithium is Li, while then lithium atom is a strong reducing agent. Strong reducing agent. After losing electron became positive ion. Then lithium positive ion is the weakest oxidizing agent. When the atom became strong reducing agent, the ion for its ion is became weakest oxidizing agent. Any reducing agent is oxidized by oxidizing agent below it. What's the meaning of this? Any reducing agent is oxidized by the oxidizing agent below it. For example, if you look at to the fluorine, chlorine, bromine, iodine. Fluorine, chlorine, bromine, iodine. Fluorine F2 displays chloride ion Cl negative and can be displaced Br negative. Br negative, and it means bromide ion, and also can displace iodide ion, iodide ions from their solution. Then for example, chlorine displays bromide ion and can be displaced iodide ion, from their solution. Bromine displaced iodide ions in their solution, from their solution. Then for example, iodide ion cannot displace Br2, and Br ion cannot displace Cl2, and for the others, for fluorine. Then fluorine can displace all the elements below it. In every redox reaction, it means oxidizing reduction reaction. There is one reducing agent and one oxidizing agent. One reducing agent and one oxidizing agent. For example, let's we study this example. We learn about oxidation and reduction. If you look at this net equation or general equation, Cl2 chlorine react with bromide ion in aqueous solution, then lead to form chloride ion Cl negative and bromine Br2. Look at to the two half equation. The first equation is oxidation equation, and the second one is reduction reaction. This is oxidation reduction reaction. If you look at to bromide ion is -1 from the reactant, but when became product, in the product Br2, the atom in pure state, the oxidation state is 0. From -1 became 0. From -1 became 0, then increase the oxidation state. This This process is oxidation reaction. And for the second one, if you look at for example, chlorine Cl2. Chlorine Cl2, it's a pure element. The oxidation number for pure element is 0. After gaining 2 electrons, two electrons became negative ion. This process is reduction. Then we can say Br increase the oxidation state. Br bromide ion increase the oxidation state from -1 became 0. But chlorine from 0 became -1, decrease, gaining electron, decrease the oxidation number from 0 to -1. Then bromide ion is the reducing agent. The oxidation state, by increasing the oxidation state, the substance reducing agent act as reducing agent, and chlorine Cl2 is the oxidizing agent. Dear students, please look at this table. This table explains all elements that we needed in reducing agent and oxidizing agent. For example, increasing the strength of oxidizing agent, and in the bottom the increasing strength of reducing agent. Look at lithium is the highest reducing agent, the highest or more strength in for reducing agent. But when losing 1 electron became +1, lithium ion, positive ion is the weakest oxidizing agent, and fluoride ion is the weakest reducing agent. But fluorine F2 is the highest oxidizing agent, and this for other elements. You cannot memorize this table, just only lithium, potassium. That's only you can learn about this oxidizing or relative strength of oxidizing and reducing agent. For continuous our subject, we have another important substance which is named by disproportionation or auto-oxidation. Disproportionation or auto-oxidation. What's the meaning of disproportionation? Disproportionation, it's this process in which a substance acts as both reducing agent and oxidizing agent. The substance in the same process in which substance act as both oxidizing agent and reducing agent. For example, we have hydrogen peroxide, H2O2. When decomposed in both oxidized and reducing agent. How? For example, if you look at this chemical equation, H2O2 is hydrogen peroxide. The oxidation number for hydrogen is +1, and for oxygen is -1. When decomposed to lead to form water and oxygen gas. Look at hydrogen +1 remain +1 in water. From hydrogen peroxide, hydrogen, the oxidation number is +1. In water also in +1. There is no changing oxidation number for hydrogen atom. Okay, but for oxygen atom -1 in hydrogen peroxide, but in water the oxidation number for oxygen is -2. Then the oxidation this oxidation number is decrease. Then this process is a reduction from -1 became -2. But in oxygen, in as comparing between oxygen in hydrogen peroxide and oxygen gas, we see that oxygen in hydrogen peroxide is -1, but when lead to form in the product, lead to form oxygen gas, the oxidation state from -1 became 0. Then oxidation, this process is oxidation. The oxidation number, the number of ion is increased from -1 became 0. And this process can be found in insect. This insect is named by bombardier. Bombardier beetle defends itself by supplying its enemies with an unpleasant hot chemical mixture of hydrogen peroxide in order to defend itself and produce. This process lead to produce hot oxygen gas. This is by this we finished this chapter. Hope you take high marks for in the exam of grade 12.